Good afternoon. We're playing with TinkerCAD today, and I'm going to introduce you to the basics of how to use an Arduino and get it set up in TinkerCAD so that you can start coding it and doing simulations with it. And everything that you do using TinkerCAD can be directly transported to the physical version when we're allowed back on site together. So first things first, I've got this void here and I've got a list of components. Now I've got in here basic and all, and then I've also got starter kits. Now we want to focus on the Arduino stuff. So if you ever wanted to know how to make a basic sort of thing, you've got here Arduinos, and these are all pre-made templates for you to work with. So if there's anything you ever needed to know specifically, that's what you can go and do. However, what we're going to do is we're going to go to basic, and we're going to manually make one ourselves. So if I scroll down, I have here the Arduino. This is an R3. We have plenty of these at school. Ours are purple, but this is a standardized microcontroller board. So what this here is, this big long black bar is, this is the processing unit. You've got USB, you've got a reset button, you've got some capacitors, and you've got a power jack to power it if you don't want to use USB for the power supply. What you have along here, you have a series of digital pins. Now these digital pins are either on or off. What you'll also notice is that there are some that say GND, because that is ground. Down here you have your power supplies, 3.3 volt and 5 volt. Most of the circuits that you work with and that you make with an Arduino are powered by either 3.3 or 5 volts. You've got 2 ground pins here to connect to, and you've also got a reset, etc. You also have these 5 analog ports. Now remember, digital is either on or off. Analog allows you to have different levels of on or off. So they can, for example, if you want to make a motor go faster, you pump more electricity into it and it will go faster and faster. So if you've got something connected via an analog connector, it can read things in much finer detail. So what I want to do here is we're going to pull up our code on the side here. Now the beauty is that TinkerCAD allows you to code in blocks, and then here you can press blocks and text, and it will create a block code and then a computer code version that will keep up to date with each other. So this code has already got, so there's already some code in here. It says set built-in LED to high. Wait 1 second. Set built-in LED to low. Now, if I look over at the code, it tells me a couple of things. It tells me pin mode. So if we go back and we look at our Arduino, pin mode 13 is set as output. Now, the Arduino has a built-in light for basically bug testing purposes, this little light here. It is also connected to pin 13, which is here, D13. So it's also a digital pin, so it's either on or off. And what this code is telling it to do is tell pin 13 to turn on. Wait for 1,000 milliseconds, then tell pin 13 to turn off. So things are either high or low, on or off. So if I run this code, by pressing start simulation, that plugs it in. The little light here comes on, and then this light here, which is the light that's connected to pin 13, on for 1,000 milliseconds, off for 1,000 milliseconds. So I can go back in here and I can fiddle with these numbers and say, okay, instead of waiting 1 second, I want to wait 50. And if I want it to be on even, so I can do this instead. And the thing is that because I've set the number so small, that light is now basically always on. So sometimes when you're doing the code for these and you're trying to use the lights properly, what you need to do is you need to give it a little bit more time. Because remember, 50 milliseconds is faster than a blink of an eye. So let's try this instead, 500 and 300. So now it's pulsing. It's on for half a second, off for 0.3 of a second. On for half a second, off for 0.3 of a second. What we can also do with these is we can create little circuits. So what I'm going to do here is I'm going to put an LED in. And I can create, that's always good practice to connect an LED to a resistor. And then I can click on the cathode and put it on the ground. So now I have this light in pin 10. I can click on the LED and I can change it to whatever color I like. So I'll say it's green. I'll go into my code, and instead of what I can do is I can delete, or rather I can put these together, and what I can do instead is I can set pin. And what I want to do is I want to go through here, I set to pin 10, and I set pin 10 to high. Then I'm going to wait. I'm also going to wait 500 milliseconds. And then I'm going to set the pin 10 to low this time. And then I'm going to wait 300 milliseconds. So now what I should have is I should have this little light here and this green light here going on and off at the same time. Well, they're out of sync, but the point is that they both go on, they both go off the way I want them to. Now, what I can eventually do is I can have a whole series of these lights rigged up in much the same way. So I could have a yellow and a red. I'll set them up each with a resistor. You want to be very, very careful when you are setting up LEDs, especially in real life, because if you pump too much electricity through an LED, it goes pop and you've ruined an LED. So you should always put a resistor on there just to make sure that there's enough, or there's not too much electricity going through. Now what we're going to do is we're going to connect this yellow one to number 9, and we're going to connect this red one to number 8. Now, these cathodes all need to be connected to a ground as well. Now there are other ways of organizing this. By the way, if I drag this around, look what happens to all my wires. My wires drag with it. So I still need to code for those lights. So what I'm going to do is I'm going to experiment with my code a little bit. I'm going to go in here and I'm going to have it so what I'm going to do is I'm going to cycle through the lights. So what I'm going to do is I'm going to set these to, we'll set these to 100 each. Now what I've got to do is I've got to remember that pin 10 is green, 9 is yellow, and 8 is red. So when you guys think about this, what am I basically creating? I'm basically recreating traffic lights. So what I'm now going to do is I'm going to go through and I'm going to change all my pins. So I've got 9, a 9, and a 9. That needs to be a 10, and then I'm going to set the other one to 8. And as you can see, as I change this, you can see my code is also changing. So I've got pin 13, pin 10, pin 9, and pin 8. And depending on how I have these set up, I can have them set to high or low, or high, high, low, or low, low, high. And now, when I press play, what this should do is cycle through the colors. So it's going through each of the colors. And depending on how well you've coded your times, they should all be for about the same distance or the same time. So I don't need this built-in LED stuff anymore. I'll get rid of that. So I'm just left with what I've got here. So now the other cool thing that we can do is we can control how fast this is. So move the code away. What I want to do is I want to put in a potentiometer. And what I'm going to do is I'm going to attach the center pin of the potentiometer to A0. I'm going to connect one to ground, and I'm going to connect the other one to power. So I have this giant knob. And what this is going to allow me to do is it's going to allow me to read what this dial is saying. All right, so what I'm going to do is I'm going to go back to my code and I'm going to look for input. And you'll see here, I've got read analog pin A0. So I'm going to get that. And then what I'm going to do is at the very outside of everything going on here, I'm going to put this in here as well. Now, when I start my simulation and I press down here the serial monitor, it has a number. If I click on the pin and I rotate it, as you can see, the numbers change. And what this will allow me to do is I can put code in here to make decisions for me. So instead of it just being on a continuously cycling loop, I can instead get it to go, well, okay, if my if my potentiometer, this little spinny thing, reads a certain value, then I want it to do a particular thing. If it's something different, I want it to do a different thing. So I can set it to 0, or I can set it all the way up to 1023. That means I have 1024 different numbers to work with when it comes to doing these things. So in here, I have a maths section and I have a control section. So what I'm going to do is I'm going to break apart what I've got going on here. Because while I need these 3 different options, I don't need them right away. So what I'm going to do is I'm going to put in here this if loop. So if then else. And I put in here another if then else. If this, then do this. Otherwise, if then do this, otherwise do this. So what this is going to always do is it's always going to check for what's inside these little rectangles. So what we need to do, what we need to put in here is we need to put in some math stuff. And what I'm going to do is we're going to set it so if 1 is less than 1, do what's in here. Otherwise, do what's in here. So I've got 2 different statements. Now, the thing is that these are also, so I can type numbers in here. But what I can also do is I can get it to read what is on these things. Read analog pin 0. If this is less than 256, set pin 10 to high. Otherwise, check to see what this pin says. If it's over 768, do this. Otherwise, do this. So now, what I can now do is if I start my simulation, and I fiddle with my thing, it goes green over a certain point. You can look at the serial monitor, the numbers float, just constantly going up and down here. And then it goes to yellow. Now, obviously, this is undesirable. I don't want this particular arrangement. So what I can do is I can go in here and I can swap low to high, high to low, start the simulation again. And now I've got, when it's on the left, it's green. If it's up the top, it's yellow. And if it's on the far right, it is red. And this is only using block coding. Now you can get more and more complicated with this. You might want to say, well, okay, what if I want to put a weight in here? so it doesn't constantly go and go and go and go and go. I can also do that as well. So I'll put a wait in here. It's going to read the whole thing, wait for 1,000 seconds, 1,000 milliseconds. So when I start the simulation, it shouldn't be going nearly as fast as it was before. So now it's only checking every 1 second. So I can move this and it might not change straight away. But what if I want to shake it up a little bit? What happens if I want it to go faster or slower? What I can also do is I can put other things into what's going on here. So for example, I can go in here and I can get one of these things. So this is called a flex sensor. And what I can do is I can plug this one into analog 1. And the 5-volt power supply. So I've got it plugged into A2. Now the beauty is that when I run this simulation, now I haven't obviously got anything turned on just yet. But when I flex this, I can click on it and I can drag it. While the simulation's running, I can click it, I can drag it. And what that's doing is it changes the angle. I can open up the code, and instead of printing what it says down here, what I need to do is I need to read what A1 is saying and print it. So when I go back to the simulation, I start the simulation and I run my code, it's saying, well, it's just giving me a whole bunch of random numbers that aren't actually going to help. But if I flex it, or A2 actually, so 0 is 1,023. If I bend it, there's a problem. Because when I'm even though I'm bending it, the result that is being picked up by A2 isn't changing. So what I need to do is I need to stop and I need to look at my wiring job, which I predict is kind of rubbish. So I'm going to delete these wires. I'm going to rewire it. So I'm going to plug this one into my 5-volt. I'm going to plug this one into my A2. I'm going to change the color of that wire. So if I double click, there, I put a kink in it. So I can just make it a little bit easier to see. And then I'm going to also take my A2 pin and I'm going to put that into I'm going to put it into the other ground instead, just to make life a little easier. Now everything is still wired up properly. If I run the code and bend it. I mean, it's still not working. All right, bit of troubleshooting. So that's one of the things you've got to remember with some of these is that there are troubleshooting steps that need to take place because they don't always work out the way you plan. So I've got my pin here, my pin 1 connected to my analog and connected to my ground. Now I actually made I made a similar one earlier today, and the big difference between this one and that is I put a resistor in. So we might need a resistor for this flex sensor so that it works properly. So we'll grab a resistor. And we'll take that to the ground. And we'll try again and see how this one goes this time. All right. So now, as the flex changes, this is also changing. So I either have a score of 33 or I have a score of 6. Now, the thing about these resistors, when you put a resistor into a circuit, especially a circuit like this, you can radically change what the serial output is going to be based on the resistance of the resistor that you are comparing it to. So this is 1,000 kilo ohms. So it's 1,000 ohms. If I change this to 500 ohms instead, what you'll see is that the bands change, like the rules that we went through before, say. And if I start the simulation again, it says 17 at its highest, and then as I bend it, it goes down to 3. So I'm changing the range with which my resistor will report. What I can do is I can also instead change it up, and I can step it up to 2,000 ohms. And now it's reading 1,008 compared to 946. So the numbers are getting bigger, but the range isn't changing all that much, which is fine. So I'm going to set this resistor back to, what's this one? Set to 1,000 ohms. All right, so I'll set this one back to 1,000 ohms. This was previously set to 2 million ohms. So let's try this one instead. So fully stretched, it's 33. And then at full bend, it's at 6. What I want to do is I want to use this flex sensor to influence how fast my lights change, or how fast this updates. So what I'm going to get to do is I'm going to get to do a little bit of math for me. I'm going to go in here. So at full flex, it's 6. Otherwise, at full stretch, it's 33. So what I'm going to do is I'm going to take this and I'm going to put this in here. So it's going to wait for 1 plus 1 milliseconds. I'm going to change that to 1 times. And then I'm going to get it to read analog pin 2. And it's going to do some math with it. So instead of reading analog pin 2, it's going to get it to times it by 25. Oh, we'll go 250. We'll go 250. And now what it's going to do is when I start the simulation, you can see down there that it's not updating very often. And what you can see is I've put such a big delay into it that it's no longer instantaneous. Because sometimes you only want things to be checking at a certain speed. Now I can yank so when it's at full bend, it's much quicker because the number is only 6. It is taking this 6, multiplying it by 250. So 6 times 250 is 1.5. So it's every 1.5 seconds. So it's going to take 1.5 seconds between me moving it and it doing its next test to check which lights to turn on and off. And you can also replace this with any other sort of sensor and get it to control the speed at which it will update these lights.